So I found a few more rational expressions that are a little bit more challenging, but same procedure as before. Try to figure out the NPVs first. So I'm going to go right to the denominator on this guy. And guess what? Yep, another PSA. You got to factor first. But the nice thing about factoring this first is you have to remember that that's going to help us later on. This, of course, is 5 times 2. Oh, negative 2. 5 plus negative 2 is going to be, of course, 3. 5 and negative 2. There's our factor of our bottom. So we can actually put this down as x plus 5, x minus 2 here. But break it down. X plus 5, we know, cannot equal to 0. Because, again, if it makes it 0, the denominator is 0, and we can't have a 0 denominator, blah, blah, blah. Okay, all right. So we know that already. Let's just do it. Okay. Minus 5, x cannot equal to minus 5. Plus 2 on this. Of course, x cannot equal to plus 2. Okay, so now with the NPVs out of our way, and the fact that we factored the denominator here, this becomes a lot easier to do. Let's look at factorization of this. Okay, guess what? It's another PSA. But like PSAs, like we do all the time, this is a PSA 2 because there's a number up front. So we got 2 and minus 10 as our PSA. So PSA, here we go. Minus 20 plus 1. That's going to be 5 times minus 4. 5 plus minus 4, and if you remember, factoring this means that you don't get an instant answer. You have to go through a process of, decomposition. Oh, makes it an extra step, but that's one of the reasons why I'm saying if you are liquid with factoring, this becomes a walk in the park. Take out an x, you got a 2x plus 5. In this case, you take out a minus 2, you get what? 2x plus 5. And your factors then are 2x plus 5 and x minus 2. And check this out. Look what can cancel. Look at this. X minus 2 are gone, leaving you an answer of 2x plus 5 over x plus 5 with non-permissible values of that. Pretty straightforward and pretty easy, isn't it? All right. How does this become challenging? Well, you're just going to have to make these guys a little bit more difficult to do. And I'll show you how to do that right now. Look at the bottom. Look at this. Again, what can you factor out of that? Of course, you can factor out a 2, leaving you a 4x, right, minus 3y. Now, can we have non-permissible values for this? Well, of course we can have non-permissible values, because if this was ever to equal this guy, one is subtract from the other, oh my goodness, you got a problem here. So we cannot have 4x minus 3y cannot equal to 0, or basically 4x can never equal to 3y. Because if you do, guess what? You got a non-permissible value. Okay? That's what's really, really important. And if you think about it, think of the values that could possibly make this 0. It's actually kind of easy because it's based on common denominators. If you make the x equal to 3 and the y equal to 4, look what you got. 12 equals to 12, and that's not allowed. But how do you say what are the non-permissible values for this if you've got 2 variables? Just solve it down to here and that's good enough. That tells everybody don't let those 2 values equal each other and you're good. Okay, so let's go back to the top here. Look, I've already factored this guy to this. So I'm just going to put it over 2, 4x minus 3y. Now, check this out. Check this out. This is, again, if you know what you're doing, it's actually really easy. You should recognize that, guys, the difference of squares, right? That's square rootable, that's square rootable, that's a difference. So square root of 1 is 4x minus 3y and 4x plus 3y. And look what cancels. Check it out. 4x minus 3y. 4x minus 3y cancels, leaving you with 4x plus 3y all over 2, and that is your answer. Okay? And the non-permissible values right here have been stated. Okay? So that's how you do questions like this. As we get better and better at this, questions, of course, are going to get a little bit more complicated. But really, if you know your factoring, it's not that tough. See?